All right, Algebra 1, Lesson 31 and Lesson 32. Lesson 31, I'm going to kind of have to look at my screen because it's cutting a whole bunch of stuff off on our smart board here. Lesson 31 is using rates, ratios, and proportions. I guess it is kind of there, although some things are missing. So a ratio is a comparison of two quantities using division. So example, if we're talking about 2 boys to 3 girls, right? We can show that ratio in 3 different ways. We can say, 2 to 3, 2 boys to 3 girls. Wow, and my calibration's way off here too. 2:3 or 2/3. Okay, hopefully we're familiar with all of that type of information on how to show ratios. A rate is a ratio that compares quantities measured in different units. For instance, rates that we use. Is there any rates that you can think of that we use? Because there's a couple of obvious ones, but I want to see if you can think of those before I say them. Miles per hour is a good one. Okay. What else? So, really, the word that should be an indicator here is whenever we use the word per, right? Per means division, P-E-R, right? Is there anywhere else where we use the word per something else, besides miles per hour? What's that? Okay, so we're dealing mainly with distance over time, right? But we also deal with different types of rates, right? Rather than just distance over time, we could talk about calories per ounce, right? Where else? Gallons per minute. Right, you could figure out the rate at which a gas pump pumps gas, right? Or any other kind of thing, it's pumping in gallons per hour or something like that. How about calories per ounce? Right? If we're talking about looking at food and seeing, how many calories are in a given ounce, maybe that doesn't really matter to you now. It will as you get older. Your metabolism slows down and you start to get fat. You're going to start worrying about how many calories are in the ounces. When you start paying for things, right? Again, we go back to the gas pump and we talk about dollars per gallon, right? I think it's something like 237, 238 is what I checked out this morning, right? So those are different rates, and rates are where we deal with a ratio of different amounts of things and even different types of units, okay? So we can get feet per second, we can get how many apples for how many dollars? 15 apples for $6, 25,000 hits per month. You can look at, YouTubers, right? They look at that kind of thing. How many likes did they get in a certain amount of time? How many views per day? Those types of things. So a unit rate is a rate whose denominator is 1. A unit price is the cost per a single unit. Okay. Miles per hour is a unit rate because we're talking about how far we're going to go for a single hour. Okay. 200 or $2.50 per box, right? How many boxes are we going to buy? So on and so forth. Okay. Proportions is the comparison of two ratios. Okay. The equation, gosh, give me a second here. I'm going to try to see if I can align some of this here real quick before I. All right. Well, we can't calibrate, so we're going to have to work on something else. All right. So we're going to talk about. You should have learned before now how to cross, multiply, and divide, right? On how to solve proportions. Or 3/5 is equal to 9/15. 9/15. 3/5 is the reduced 9/15, right? If I divided each of those numbers by 3, I'd get 3/5. That's a proportion. It's two rates that are, or ratios that are equal to each other. So cross products property, if A over B equals C over D and B doesn't equal 0, right, meaning that I don't have a divide by 0 error, then AD, okay, cross multiply down from top left to bottom right, AD equals BC, bottom left times top right. Okay, those two things equal each other, we can solve. Okay, in this proportion, AD and BC are the cross products. Proportions are used to represent many real-world situations that require finding a missing value. Using the cross, let's fix some typos here. And it looks like we have some information that's Done fall off our screen. Using the cross products is an efficient method for solving the proportions. So we'll cross multiply. Proportions are frequently used to solve problems involving variations of what we call the distance formula. Distance equals rate times time. Okay, we'll also rewrite that, and basically all we've done is move the variables across. So rate equals distance divided by time. If I'm looking at d equals rt and I want to solve for r, I would divide by t on both sides, correct? So r would equal d over t. And the same thing, if I had d equals rt and I want to solve for time, I'm going to divide by r on both sides. So time equals distance over rate. Does all of that make sense up to this point? It's really important that you understand it now because we'll continue to work with it further and further on. Okay? Let's see, I believe that should say lesson 32, not 31. Let's make sure that we do have the right things here. Simplifying and evaluating expressions with integer and zero exponents. So let's make sure that we understand that this is coming from lesson 32. Okay? All right. And can you guys see this in full on your screen? Like it's not cut off for you guys? Okay, good. So you guys are able to read it even if we can't really see it very well up here. So algebraic expressions may contain exponents that are positive, negative, or zero. The relationship between the different exponents can be understood by looking at successive powers of a positive integer greater than 1. So if we look at things like, taking numbers to an exponent, right, we see 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4, 2 to the 1st is 2. All of that makes sense, right? Okay, what we're going to look at is what happens as we get smaller and smaller. We want to see the relationship of 2 to the 4th in comparison to, say, something like 2 to the negative 4th, right? 2 to the 3rd in comparison to 2 to the negative 3rd, 2 squared in comparison to 2 to the negative 2nd, so on and so forth. What you'll notice, do we see a pattern as we go 4, 3, 2, 1, and we get 16, 8, 4, 2? What happens? The numbers are divided by 2, right? Okay, so what's 2 divided by 2? 1. So 2 to the 0 should be what? No? 1, right? As I go down an exponent, I should be dividing by 2, right? Okay, so if I get 0, 2 to the 0 is 1, then I would continue. What's 1 divided by 2? What is it? 1 divided by 2. You guys are making this too hard. A half. Did somebody say 2? I hope not. No. 1 divided by 2 is not 2. Okay? That means, all right, what would come after 0? Negative 1. So 2 to the negative 1st is 1/2. Right? Does anybody know what 1/2 divided by 2 is? 1/4. So 2 to the negative 2nd would be 1/4, right? And what we would begin to see is as we continue to go negative, 2 to the negative 3rd is going to be 1/8, and 2 to the negative 4th is going to be 1/16. You're right, okay? And that's what we see as we follow this on down, okay? Okay, the power of 2. In fact, anything to the 0 power is always what? No, 1. Anything to the 0 power, anything is 1, okay? So we get 2 to the negative 1st is 1/2, or 1 over 2 to the 1st, right? Because we would pull that down below the division bar, right? So 2 to the 1st is 2. That gives me 1/2, right? If I put 1 over 2 squared, that's going to be 1 over 4, and we'd keep going that way. Does that make sense? So we understand that as we take a regular positive integer to a negative exponent, that what we wind up with is a positive fraction, okay? Okay, so the pattern illustrates the rule for negative and 0 exponents. Negative and 0 exponents. So the rule of negative exponents is this: for every non-zero number where I have, let's say, x, that number to the negative exponent is going to be 1 over that number to the positive exponent. Okay? And let's see, let me kind of slide it over so I can still see it, even though. Okay? And then if we had x to a positive exponent, that would really be equivalent to 1 over that number to the negative exponent, which we wouldn't normally do. Okay? The zero exponent rule is that whatever number I'm taking to the power of 0 will always equal 1. So an algebraic expression is not considered simplified if it contains negative or 0 exponents. Okay? If we want to say that we've simplified it, we want to get positive exponents. We want to go ahead and find out what it is to that exponent. So the product rule for exponents applies to negative and 0 exponents. Okay, then we have our quotient rule. Quotient rule for exponents is used when dividing algebraic expressions. This rule states that to divide two algebraic expressions with the same base, we subtract their exponents. So if I got a number over a number, they have the same base, I'm going to subtract them up. Okay? All right, so if m and n are real numbers, x doesn't equal 0, then x to the m over x to the n is x to the m minus n, or 1 over x to the n minus m. Okay, depending upon if I'm moving it up or down. Follow me so far? Okay. All right, so if I had 5 to the 4th over 5 squared, that'd be 5 to the 4th minus 2, or 5 squared, which is 25. Or if we had it in reverse, right, where we had 5 squared on top, 5 to the 4th on bottom, I want to bring that 5 squared down, right? That's going to give me 1 over 5 to the 4 minus 2, which is 1 over 5 squared, right, which is 1/25. I know I've gone through this kind of quickly, but hopefully it makes sense. Okay, cool. All right. I think we can see most of what's up here. Again, I don't know that I can actually write on the board. So let's look at some questions. And this will go back to lesson 31. A store sells 4 batteries for $2.80. Which deal is better? 10 for $6.75, 8 for $6, 2 for $1.60, 6 for $5.10. How would we go about solving these? Divide, right? All right, so, and we want to, we want to find dollars per battery, right? So we want to figure out what should go on top so we know what to divide by what. So if we're doing dollars per battery, the very first thing I want to do is I want to find out $2.80 divided by 4. Is that correct? All right, what's $2.8 divided by 4? What does that come out to? What's that? So 70 cents per battery, right? I can't actually write on my board, so it's a little frustrating. All right, so you're going to have to, video-wise, you're just going to have to follow the voice. So 70 cents, I'm going to write it actually on the dry erase board. So our original is 70 cents per battery. All right, what's 675 divided by 10? Come on, guys. 67 cents. Okay, so 0.5, so let's say 68 cents. Well, that looks like a better deal, doesn't it? Okay, well, let's check the others just to see. What's $6 divided by 8? 75 cents, so that's not as good. All right, what's 1.6 divided by 2? It's probably what, 80 cents? All right, 80 cents. 510 divided by 6? That's probably not as good a deal. 85 cents. So we actually know what the worst deal is, right? It's 6 for 510. All right, so what we want is 10 for 675 is the best deal, correct? All right, so we know how to go about that. All right. Let's see. In the figure, triangle ABC is similar to triangle PQR. We want to find BC. BC. If they're similar, then they are proportional, correct? Okay, so let's look at a proportion. Again, you kind of have to follow the voice if you end up going back to watch it. Okay, so we want to compare some things. What can I compare? Do we want AB over PQ, or do we want PQ over AB? Do you guys know what I mean? All right, so let's say we're doing triangle AB over triangle PQ, right? All right. What side of AB do I know compares to PQ? 9 compares to what? 12. All right. Now, I'm trying to solve for BC, right? Is that going to go on the top or the bottom? Top. Okay, so we're going to write BC there. What should go on the bottom? QR, right? But what is the measurement for QR? 10. All right, so what math do I do to solve for BC? All right, so 9 times 10 is 90. And 12 times BC is 12 BC. And then you said we're going to divide by 12 on both sides. So what's 90 divided by 12? 7.5? 7.5 equals BC. Is that an option? Yeah, 7.5. A is my answer. Okay? Is there a weird smell in here? It's like a yeah, it's like a weird, like burning, something weird. Which, huh? I don't know. This is all being recorded, but there was a weird smell probably around this time last year. I wonder if it's not like coming up from like the art room or like one of the science rooms or something, because like I feel like a weird smell. All right, question number 3. Cereal is on sale this week. Is it better to get the 10-ounce box for $1.77 or a 14-ounce box for $3.07? So same concept as question number 1, but what do we want to put on top? It's something per something. Is it ounces per dollar or dollars per ounce? You want to do ounces per dollar? How do you normally buy things? Dollars per ounce. Okay, that's how we want to set this up. So the first one was $1.77 for 10 ounces. Is that right? Okay, what's $1.77 divided by 10? Because we want to get to a unit price, right? We want to find out how much it is for a single ounce. 0.17. Okay, so 18 cents per 1 ounce. Okay, and then on the other one, it is how much? How much does it cost? 307. All right, so 307 for 14 ounces. What is that unit price? 22 cents. Okay, so which is a better deal? 18 cents per ounce or 22 cents per ounce? 18. So we want the 10-ounce box, right? But that first thing you got to figure out is how am I going to set up the ratio, right? Okay. Let's see. So do we feel like we understand proportions okay? All right, so let's see if we can go down. Let's go down to like number 8. Okay, this is probably stuff that you want to see, correct? All right, we've got a to the negative 4th over b to the 7th, all over a to the negative 7th, b to the negative 5th, c to the negative 5th. All right, so with something like this, we want to be able to move things up and down, right? And it's all multiplication, so we can do that. If we threw an addition or a subtraction in there, with gum up the whole works, we'd have to do a completely different thing. All right, so we got a to the negative 4th, b to the 7th, all over a to the negative 7th, b to the negative 5th, and c to the negative 5th. Well, what happens to exponents as we move them across the division bar? They change signs, right? They don't automatically become positive. If they were already positive to begin with, they would become negative. So we want to make sure that we understand that they change signs as they move across the division bar. Do we want our exponents to be positive or negative? We want them to be positive. So let's look at our a's here. We've got a to the negative 4th on top. We've got a to the negative 7th on the bottom. Which one do I want to move? Do I want to move a to the 4th down so it becomes positive, or do I want to move a to the 7th up so it becomes positive? You want to move a to the 4th down? Okay, that's going to provide an extra step because what I want you to understand is when we do that, I have a to the positive fourth and a to the negative seventh. What do I do with those exponents? I add them, right? Well, what is 4 plus negative 7? All right, so I still have a negative 3, correct? Do I want that? Right? And now I could move the a to the negative 3 to the top and get it to be positive, correct? But you see how it took me, 1, 2, 3 steps to get a positive a exponent. What would be easier would maybe be moving the a to the 7th up and making that positive, okay? Because what's negative 4 plus 7? A to the third, right? Do I still get the same a to the third that I would have gotten if I moved the a to the negative fourth down and then move this solution back up? Yeah, okay? But we'll try to do it in fewer steps. Do I want to move to the b to the 7th down or the b to the negative 5th up? Okay, what happens to that b to the negative 5th when it comes up? Okay, and so then I'm going to take 7 and 5. Do I multiply or add them? Add. So what's 5 plus 7? 12. All right, so those two things have been moved up. I've got c to the negative 5th. Can I move it up? Yeah, there's no c anything in the numerator to bring down. So what happens to that c as I bring it up? C to the positive 5th. So I get a cubed, b to the 12th, c to the 5th. Right, that's what I should be looking for. Okay, questions about that? We understand how to move those things, add them. Okay, all right. Let's see, let's look at the pattern here as we go. All right, 5 cubed is 125, 5 squared is 25, 5 to the first is 5, 5 to the 0, 1, 5 to the negative first, 1/5, 5 to the negative second, 1 over 25. Can anybody see a pattern going from left to right? What are we doing there? Dividing by 5? Go ahead and check. What is 25 times 5? Is that 125? Okay, 25 divided by 5 is 5. 5 divided by 5 is 1. 1 divided by 5 is 1/5. And 1/5 divided by 5 is 1/25. So do we all understand that the pattern is that we divide by 5 as we move from left to right? Great. All right, let's look at number 10. Evaluate a to the 0, b to the negative third for a equals negative 3 and b equals 4. Okay, so we would sub in, correct? But what is anything to the 0 power? 1, so does it matter what goes in for a? No, so what I'm left with is just what? 4 to the negative third, is that right? Okay, so let's figure out what 4 to the negative third is. Can I drop that below the division bar so that 4 gets a positive exponent? Yeah, it's the same thing as if this had been x to the negative third, right? We would make that 1 over x cubed, correct? So can I do the same thing here? The only difference is that I can go an extra step to simplify, right? What is 4 to the third? 64, so I should get 1/64. Okay, you got a calculator there with you? Somebody tell me what 4 to the negative third is whenever you plug it in your calculator. You might have to hit math fraction because it'll probably give you a decimal. What did it say? Do you guys know what I mean by math fraction? No? All right, let me show you. Okay, so if I bring this guy over here and I want 4 to the negative third, right? See how I get a decimal? If I get a decimal and I want a fraction, I can hit math. Notice that the very first thing that pops up is FRAC, which is short for fraction. I can hit enter and hit enter again, and it'll give it to me as a fraction, 1 over 64. Is your mind blown? Okay. All right. All right. Well, let's see. Do we feel like we've kind of got an understanding of both these lessons? You sure? We've got a lot of other questions in here. All right. Let's see. Let's look at something like, look at 20. 20. What's that answer going to come out to? Anybody know? It's just y, right? Because what do I want to do with that y to the negative first? bring it up, right? So it becomes y to the first. Do I need the first? It's just y, right? The same way with 21. That's going to be into the 12th, right, as I bring it up. With 22, I'm just going to switch places. So I'm going to get b to the 9th over a to the 6th, right? That's how I'm going to get positive exponents there. Same thing with 19. 19 is going to be y squared over x cubed. Okay, do you follow me? Okay, cool. All right, we'll close it down there.